Students, we already start our new chapter, atomic structure. In previous classes, we are discussing about subatomic particles introduction and also few atomic models. And now today class, we are coming to students some important basic terms in atomic structure chapter. Students, among them, the first one is, dear students, isotopes. Very important one. Students, isotopes. Now let me come into the definition of isotopes. Students, isotopes are the atoms of same element, which are having same atomic number, dear students, but different mass number. And that atoms of same element which are having same atomic number but a different mass number, we call them as simply isotopes, dear students. Now let me coming to the examples of such type of isotopes. Here I am interested to define isotopes of hydrogen. We just look at isotopes of hydrogen. This is 1H1 and this is 1H2 and this is 1H3 and 1H1 we call it as simply protium and 1H2 we call it as simply deuterium and 1H3 we call it as simply tritium. So these are simply isotopes of hydrogen. You know why? Because these three species having same atomic number, students, but a different mass number, keep in mind. Let me come into another example, chlorine isotopes. Chlorine, we know, atomic number 17 with a mass number 35, one of the isotope. And this is chlorine with atomic number 17 and a mass number 37. This is another isotope, students. So now let me come into the definition once again. Atoms of same element. Can we just look at these three isotopes belongs to hydrogen atom, means atoms of same element which are having same atomic number but a different mass number. Here mass number of protium 1, here mass number of deuterium 2, here mass number of tritium 3. So mass number differ but atomic number same, and that type of species what we call simply isotopes, dear students. Students, we know one thing, in isotopes atomic number is same. Atomic number is same means, dear students, the number of valency electrons same. Okay now, so number of valency electrons is the same in isotopes. Because atomic number 1 means, dear students, each and every isotope of hydrogen has one valency electron. Keep in mind. Okay, so since number of valency electrons in isotopes being same, and that is the reason behind why, dear students, isotopes, keep in mind always, isotopes exhibit, dear students, similar chemical properties. You know why? Because chemical properties mainly depends upon how many valency electrons present inside the atom. If number of valency electrons are same, obviously their chemical behavior is also same, and that's why isotopes exhibit similar chemical properties, dear students. But while we coming to students, their physical properties, generally physical properties depends on weight. Physical properties means what? So physical properties means, students, their melting point, their boiling point, their density. So all such physical properties majorly depends upon what, you know, students, physical properties mainly depends upon mass number. Keep in mind. But in isotopes which are having different mass number, their physical properties obviously differ, dear students. And that's why isotopes exhibit similar chemical properties, whereas their students, but they exhibit, their students, different physical properties. Keep in mind, different physical properties. And another important factor while we discussing about isotopes, dear students, the fractional mass. Keep in mind, the fractional mass of an element is also mainly due to, dear students, mainly due to the existence of isotopes. ఎందుకు సార్ ఫ్రాక్షనల్ మాస్ వస్తుంది, అటామిక్ మాస్? ఫ్రాక్షనల్ మాస్ అంటే సార్, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ క్లోరిన్ తీసుకున్నాం అనుకోనన్నా, దీని యావరేజ్ అటామిక్ మాస్ ఎంత? 35.5. బొరాన్ తీసుకున్నాను అనుకోనన్నా, దీని యావరేజ్ అటామిక్ మాస్ ఎంత? 10.5. ఎందుకు సార్ ఫ్రాక్షనల్ మాస్ కనబడుతుంది ఫ్యూ ఎలిమెంట్స్ కి? The fractional mass of an element is also mainly due to the existence of more than one isotope. Keep in mind. We just look at chlorine, which exists in two different isotopes. One is 35 mass number, another one is 37 mass number. If we want to calculate the average atomic mass of chlorine by using formula, I am ready to give that formula, of course. We are ready to calculate its atomic mass. Finally, we got an answer 35.5. We just got an answer 35.5. So, the fractional mass of an element is also mainly due to the existence of isotopes, dear students. Keep in mind. Okay, now, so this is the basic introduction of, first of all, dear students, what are isotopes? Now, students, we are ready to know about the formula which is calculated to the average atomic mass of an element. Yes, students, most important one, the average atomic mass of an element. We have formula summation AI xi by summation xi, dear students. Sir, what is AI, sir, here? Dear students, AI is nothing but atomic mass. Students, sometimes atomic mass may also be called atomic weight. Keep in mind. So atomic mass or atomic weight of isotope of that element. Isotope of that element. And what about xi, sir? Dear students, what about xi, sir? Xi is nothing but, dear students, the percentage abundance of that isotope, dear students. Percentage abundance of that isotope. If one element existing three different isotopes, keep in mind, three different isotopes. Now, what is average atomic mass of that element, sir? It's clear that three isotopes means this formula further extended to 3 times. Means, sir, means A1 x1 plus A2 x2 plus A2 x3 by 3 times extension nana for xi means x1 plus x2 plus x3, dear students. So this is the formula to calculate the average atomic mass of an element. You well understood, dear students? You well understood this particular model. Now let me coming to one important previous problem. An objective examinations point of view, please look at the mass number of 3 isotopes of an element or dear students, 10 comma 12 comma 14 units respectively. Keep in mind, is already given mass numbers of 3 isotopes. Students, their percentage abundance is, keep in mind, their percentage abundance is simply 80, 15, 5 units. Now the question is, would you please calculate, dear students, the average atomic mass of that element, average atomic mass of that element. అయితే ఆ ఎలిమెంట్ యొక్క యావరేజ్ అటామిక్ మాస్ ని క్యాలిక్యులేట్ చేస్తారా? దిస్ ఇస్ ద క్వశ్చన్. స్టూడెంట్స్, while we coming to the answer, we have formula for the average atomic mass depends on that element exists in how many number of isotopes. The question clear that the element exists in 3 isotopes, and that's why my formula, dear students, A1x1 plus A2x2 plus A3x3, I'm sorry, this is A3 okay, by students x1 plus x2 plus x3. Is it clear? Students, is it clear? And now, while we coming to A1, sir, what is A, sir? Atomic mass of isotope of that element. Sir, what is X, sir? The percentage abundance of that isotope. While we coming to first isotope, its atomic mass is 10. Atomic mass, nothing but mass number. Okay, that is 10. And its abundance what, sir? It abundance 80%. Keep in mind. Okay, and that's why for first isotope, atomic mass is 10 units. And its percentage of abundance is 80. Keep in mind. What about second isotope, sir? Second isotope atomic mass is 12. And its abundance, sir, it abundance 15%. What about third isotope, sir? Third isotope atomic mass means mass number 14. And its abundance is 5, dear students, by total abundance. Students, once again I recall, if we summarize all these, 80 plus 15 plus 5, dear students, 80 plus 15 plus 5, we get ultimately 100%. Because the percentage we are already calculated under an amount 100. Keep in mind. అందువల్ల డైరెక్ట్ గా ఇక్కడ మనం పర్సెంటేజ్ అబండెన్స్, టోటల్ పర్సెంటేజ్ అబండెన్స్ ని మనం 100 కింద కన్సిడర్ చేయించానన్నా నో ప్రాబ్లం. సో ఇఫ్ యూ డన్ calculations, dear students, after multiplication we get this is 1050 by 100, dear students. And that's why simply the average atomic mass of that element, what's are the average atomic mass of that element, dear students, and that is 10.5. Keep in mind. Very very important one, students, in examination point of view, this type of model problems. Students, here we have another important problem in objective point of view. This is previous examinations point of view, mains and NEET particularly. The thing is, he is already given chlorine exists in 2 different isotopes. One is having mass number 37, another one is having mass number 35. Now let me write what is going on here while you come to the answer. Chlorine 37 is one of the isotope, and chlorine 35 is another isotope. The average atomic mass is already given 35.5. The thing is, we are ready to calculate the percentage abundance of each isotope of chlorine. Keep in mind. Means, students, just imagine ourselves the chlorine 37 isotopes abundance. For our convenience, students, say its abundance some X percentage. Keep in mind. What about chlorine 35 abundance, sir? We already know, dear students, the total abundance of all isotopes of one element is absolutely 100%. Okay. So one of the isotope X percentage. What about the another isotopes, sir? అరే మొత్తం abundance 100% కదా నాన్న, అందులో ఒకటి X percentage అయితే మరి రెండొక ఐసోటోప్ యొక్క abundance ఎంత అవుతుంది సార్? The abundance of second isotope is, dear students, 100 minus X percentage. Keep in mind, that is 100 minus X percentage. So students, we are ready to calculate average atomic mass now. Keep in mind, average atomic mass. Existing two isotopes means the formula simply A1X1 plus A2X2 by X1 plus X2. The average atomic mass, it is already given 35.5. What about first isotope mass numbers are 37, means 37 into, what about its abundance, so it abundance X percentage, means X, plus what about second isotopes are, second isotope mass number 35, dear students, into what about its abundances are 100 minus X, keep in mind, by X1 plus X2 nana, total abundance is already 100%. While we go for the calculations, we have just multiplied with 100, 3550, and this is 37x, and this is 3500 minus 35x. ఈ 3500 ని పక్కన తీసుకొస్తే I think 50. What about 37 minus 35 are 2x. Then absolutely what is x are 25, dear students. What is x? Chlorine 37. Keep in mind. It's clear? And that's why the abundance of, dear students, the abundance of chlorine 37 is absolutely 25%. What about the abundance of chlorine 35 are 100 minus x, dear students, 100 minus x means 100 minus 25, 75%. Keep in mind, students, and that is absolutely 75%. Keep in mind. Most important problem, students, most important model, particularly in previous NEET and mains examinations, very important problem. Keep in mind. Is it clear, students? Are you got it? ఈ మోడల్లో వచ్చే ప్రాబ్లమ్స్ అన్నీ కూడా మనకి ఇంపార్టెంట్. Students, this is about isotopes, and then I am coming to my next definition, isobars. Very important one, students. Isobars. Now let me define what are isobars. Isobars means, students, atoms of different elements. Keep in mind, atoms of different elements which are having, dear students, same mass number. Mass number appears to be same, but, dear students, different atomic number. Atomic number is different. Isotopes ki reverse anamata. Okay na? Isotopes aithe same atomic number, different mass number. Isobars aithe same mass number but different atomic number, dear students. Students, while we coming to few examples of isobars, now let me explain carbon and nitrogen. Carbon atomic number 6, it exists with the mass number 14. Nitrogen atomic number is 7, it exists with the mass number 14. Means carbon and nitrogen are atoms of different elements, not same. Carbon, nitrogen, different. But both are having same mass number 14 and 14, but a different atomic number 6 and 7, keep in mind. And that species which are having same mass number but a different atomic number, we call them as simply isobars. Let me come into another example, argon, students, potassium, calcium. We know their respective atomic numbers 18, 19, 20. But each and every element here exists with a mass number 40, dear students, keep in mind. Okay, and that's why this is another example for isobars which are having different atomic number but same mass number, keep in mind. While we coming to the behavior of physical and chemical properties, dear students, we know one thing. Here this is atomic number 6, means the number of valency electrons. Students, the number of valency electrons. 6 means how many? 4. First shell TCL kada 1s2, 2s2, 2p2. 2s2, 2p2 ne outermost shell avutundi. Okay na? What about nitrogen, sir? Dear students, the number of valency electrons 5. 1s2, 2s2, 2p3. Okay na? 2s2, 2p3 kabatti 5. Different valency electrons. Different valency electrons. And that's why, students, remember one thing, isobars are always having different chemical properties. Different chemical properties. Because their atomic number is different, keep in mind. But their mass number is same. Mass number is same. Physical properties depends absolutely on mass number. And that's why isobars having similar, dear students, physical properties, keep in mind. So they are having similar chemical properties, dear students. And these are the second important basic term, isobar. And students, now let me come into the third important one, isotones. Keep in mind, students, isotones. What are isotones, sir? Dear students, isotones are simply the atoms of different elements. Keep in mind, no doubt at all. Atoms of different elements, but which are having, dear students, which are having same number of neutrons. Keep in mind, same number of neutrons. Let me come into one example here, dear students. I am ready to choose carbon with the atomic number 6 and mass number 14, and oxygen atomic number 8 and a mass number 16. If you are ready to calculate, dear students, number of neutrons in each species, we know the formula to calculate number of neutrons, mass number A minus atomic number Z. And that's what we call A minus Z. Students, very, very important one, A minus Z. Means atomic number minus, mass number minus atomic number. Means 14 minus 6, 8 neutrons here. 16 minus 8, 8 neutrons here. So these two species are atoms of different elements. The one is carbon, another one is oxygen. But both are having same number of neutrons, and that's why these are simply called isotones, dear students. Students, while we coming to another example here, sodium with 11, 23 and magnesium with 12, 24. Would you please look at number of neutrons? 23 minus 11, 12, 24 minus 12, 12, obviously same number of neutrons. Okay. Sir, what about their physical and chemical properties, sir? Very, very interesting one. What about their physical and chemical properties? Dear students, isotone exhibits, what about their atomic number? Difference or different atomic number. Different atomic number means obviously different chemical properties. No doubt at all. Different chemical properties. What about their mass numbers, sir? Mass number also different. Means different physical properties, dear students. So isotopes exhibit different chemical properties and different physical properties because their atomic number is different and also their mass number is different, dear students. And these species what we call simply isotones. Students, and after that one I am coming to another important definition, isodiaphers. Very important one, students. Isodiaphers. Sir, what are isodiaphers? Sir? Very interesting one. Isodiaphers is nothing but the atoms which are having the same isotopic number. Keep in mind, same isotopic number. Isotopic number means what, sir? Dear students, isotopic number means A minus 2Z. That's what we call isotopic number. A minus 2Z means what, sir? A minus 2Z means A minus Z and along with minus Z. A minus Z means what, sir? Mass number minus atomic number. Dear students, number of neutrons, keep in mind, minus atomic number. Atomic number obviously differ what? Obviously represent what? Number of neutrons. Okay. So, isotopic number means either A minus 2Z or, dear students, difference between number of neutrons and protons. Keep in mind. So, difference in number of neutrons and protons n minus p anna ledu A minus 2Z anna kuda we simply call it as isotopic number. Very important one, dear students. So, same isotopic number ఏ ఐటమ్స్ అయితే ఉంటుందో ఆ ఐటమ్స్ అన్నిటిని కూడా మనం సింపుల్ గా ఐసోడయాఫర్స్ అని పిలవచ్చు. Very interesting one, dear students. So, we simply replace this word the nuclides. The nuclides which are having same isotopic number. Now, let me give an idea with a few examples here, students. Fluorine, atomic number 9, dear students. Are you have any information about its mass number? 19. And sodium, 1123. If you want to calculate their n minus p value, number of neutrons minus protons, number of neutrons, mass number minus atomic number, is not it. Ante 19 minus 9, ఇది neutrons minus protons. Protons nothing but atomic number. 19 minus 9, dear students, 10. 10 minus 9, 1. So, difference in number of neutrons and protons is absolutely 1. What about sodium species? So, sodium species, number of neutrons, students, 23 minus 11 minus number of protons, I think this is 11. So, 23 minus 11, 12, 12 minus 11, 1. So, same n minus p or same A minus 2Z, and that species, that nuclides, what we call simply isodiaphers, dear students. Very important one in objective point of view. Isodiaphers, same isotopic number A minus 2Z or the same difference in number of neutrons and protons, keep in mind. And students, now let me coming to another important definition, isostats. Isostats. Isostats means what, sir? Isostats means the molecules, dear students, which are having same atomicity. Very, very important one. Same atomicity means what, sir? Same atomicity means, dear students, same number of atoms in that particular molecules. Now let me come into an example, students. CO2 and N2O. These two are isostats, no doubt at all. How can you confirm isostats, sir? How many atoms are in CO2, Nana? The one is carbon, and two oxygen atoms, Nana. So 1 plus 2, Nana. 3, the atomicity of CO2, 3. What about N2O, sir? 2 nitrogen atoms, Nana. 1 oxygen atom, 2 plus 1, 3. Same atomicity. So the molecules which are having same atomicity, we call them as isostats. Keep in mind. Same atomicity means, dear students, same number of atoms. And another interesting one is benzene and borazole. Another important example. This is benzene. We know your lower classes very well. And this is borazole. How many atoms are there in each species? Calculate. 6 plus 6. 12. 3 plus 3 plus 6. 12. Same number of atoms. Same atomicity. We call it as isostats, dear students. Students, and the last one we are ready to discuss here, isoelectronic species. Very, very important one. Isoelectronic species. Isoelectronic species means what, sir? Isoelectronic species means the species which are having same number of, dear students, same number of, just look at iso, same, electrons means the species which are having same number of electrons. We call it as isoelectronic species. Keep in mind. Now let me come into few examples for isoelectronic species. Dear students, N-3, O-2, F-1, Na, sodium +1, magnesium +2, aluminium +3. Students, while we calculating number of electrons in each and every one, nitrogen actually atomic number 7, but it gained 3 electrons. So 7 plus 3, 10. What about oxygen, sir? Atomic number 8, means 8 electrons actually, but it gained 2 further. 8 plus 2, 10. Here 9 plus 1, 10. What about sodium, sir? Actually 11 atomic number, 11 electrons. Plus 1 means lose 1 electron. 11 minus 1, 10. Like magnesium, 12 minus 2, 10. 13 minus 3, 10. So all are having how many number of electrons, are 10 electrons. So the species which are having same number of electrons, we call them as isoelectronic species, dear students. So this is today class, students. Very, very important basic terms. మీరందరూ లెసన్ విన్నాక మీ లింక్ వస్తుంది మీ యూట్యూబ్ ఛానల్స్కి, ఓకేనా? సో లెసన్ అంతా అయిన తర్వాత నా యూట్యూబ్లోని మీ కామెంట్ ప్లేస్ చేయండి, ఒక చిన్న మెసేజ్, సార్ అర్థమైంది, బాగుంది, ఓకేనా? ఈ రకమైన కామెంట్ ప్లేస్ చేస్తే నాకు చాలా హ్యాపీగా ఉంటుంది పిల్లలు. ప్లీజ్ ఓకేనా? థ్యాంక్ యూ నాన్న. అండ్ టుమారో క్లాస్ we are discussing another important topic in atomic structure. Thank you students, each and everyone. Bye.